This is a simple question of superposition of SHMs. We've been given 3 SHMs of equal amplitude and of the same time period, that is the same frequency, in the same direction, and they combine. The phase of the second is 60 degree ahead of the first and of the third is 60 degree ahead of the second. We need to find out the amplitude of the resultant SHM. Let x1 is equal to a sin omega t, then x2 is equal to a sin omega t plus 60 degree, and x3 is equal to a sin omega t plus 120 degrees. Now the resultant SHM will be equal to x is equal to x1 plus x2 plus x3 is equal to a sin omega t plus a sin omega t plus 60 degree plus a sin omega t plus 120 degrees. So now let us club the first and the third term. So it becomes a sin omega t plus sin of omega t plus 120 degree, and we have a term of sin of a sin of omega t plus 60 degree left here. Now solving this, we get a 2 sin c plus d by 2 omega t plus 60 degree cos of c minus d by 2, that is equal to 60 degree, plus a sin omega t plus 60 degrees. Now this cos 60 cancels with the 2 here, so we get 2a sin omega t plus 60 degree. So the final amplitude of the resultant SHM comes out to be 2a, but this is not a very good method. Over here we were able to find out two terms who added up to give this term, but this may not happen in all the cases. So a better and simpler solution for this question is by the concept of phasor diagram. Whenever you need to add SHMs in the same direction, x1 is equal to a sin omega t plus a sin omega t, x2 is equal to a sin omega t plus 60 degrees, and x3 is equal to a sin omega t plus 120 degrees. You draw the phasor diagram for each of these three, assuming these three to be vectors. I'll tell you how to draw them. This is the line of omega t. The magnitude of the vector or the length of the vector will be proportional to the magnitude of the SHM over here, and the phase angle, this can be written as omega t plus 0 degree. So this will be drawn as a vector of magnitude a along the x-axis. The second one is again a vector of magnitude a, but it is an angle of 60 degree from the x-axis because it is 60 degree ahead of this vector. Therefore we draw it anti-clockwise 60 degree at an angle of 60 degree. This is x2, this is x1. The third one can again drawn to be a vector with magnitude a and which is 120 degree ahead of this vector. Therefore it is drawn on this side x3. Again the magnitude of this vector is a. This phasor diagram is used to find out the amplitude of the resultant vector always. The amplitude of the resultant vector will be equal to the amplitude of the resultant when we calculate the resultant for these three vectors using vector formulas. So here for finding out the resultant of these three vectors, let us first find out the resultant of these two vectors. Since these two vectors are equal in magnitude, the resultant will come along the angle bisector of these two vectors, that is along 60 degree. So the resultant of these two vectors comes in this direction. Let us find out the magnitude of the resultant. That comes out to be root over a square plus 2a into a cos of 120 degree. That is equal to root over a square plus a square. This becomes minus half. So this becomes minus a square. So this a square gets cancelled with this a square to give us a. So these two vectors can now be rubbed. Let me redraw it. So the system becomes a vector of magnitude a which was already there, and the resultant of these two vectors is again a vector of magnitude a in this direction. So the final vector becomes of length 2a in this direction. Therefore, by this we can say that the amplitude of the resultant SHM will be equal to 2a, and the resultant SHM will be leading the, we can also write the equation directly from here. The resultant SHM will be equal to 2a sine omega t plus 60 degree, because this 60 degree tells us the phase angle of the resultant SHM as to how much phase angle is it ahead of omega t. So the final answer for the amplitude of this resultant SHM comes out to be 2a.